The goal in each of these problems is to simplify them as completely as possible. And we're going to start off with this first one, which says the square root of 45. Now, it doesn't say to give an approximate value for this. It says to simplify this. So if I went to my calculator and typed in the square root of 45, it would give me a decimal 6 point something something something. That's not what we're looking for. That's not a simpler answer. That is an approximate answer. Rather, we're looking to put this into simplest radical form. And to do that, we want perfect squares. I know that the square root of 4 is equal to 2. The square root of 9 equals 3. The square root of 16 is equal to 4, and so forth. These numbers are perfect squares. 45 isn't on that list. What I want to do is find a number that is on the list of perfect squares that goes into 45. So let's just make a quick list here. 4, 9, 16, 25, 36, 49, 64, 81, 100. These are all perfect squares. One number times itself gives us each of these. These are our perfect squares. So from this list, I'm looking for a number that goes into 45. These big ones are obviously too big. 36 doesn't go into it, nor does 25. 45 divided by 16 doesn't come out to a whole number. 45 divided by 9 is equal to 5. So we can rewrite this as the square root of 9 times the square root of 5. And the reason why this is nice is because I know the square root of 9. The square root of 9 is equal to plain old 3. The square root of 5, I don't know that one either, so I'll keep it like that and say this is my simplified answer, 3 square root of 5. The next example with the square root of 60. So again, I'm looking on the same list. Which of these numbers goes into 60? And this time, since it's an even number, I'm going to try 4. And it works out that the square root of 4 times the square root of 15 is 60. The square root of 4 is 2. The square root of 15, if I would looking to break that one down, I know that 5 times 3 is 15, but neither of those numbers are perfect squares. I don't know the square root of 5. I don't know the square root of 3. I didn't know the square root of 15. So the square root of 15 is going to stay that way, and root 60 breaks down to 2 root 15. Here's our next one with the square root of 200. This time we have some choices. 4 goes into 200. 25 goes into 200. And even 100 will go into 200. My suggestion is to always go for the biggest one. You could use any of those pairs to make it work, but the biggest one will be the easiest. I'm going to show you 2 ways to do this one, starting off with using smaller numbers. So the square root of 200 would be 4 times 50. So that works. The square root of 2 is 2, but the square root of 50 can break down further, because that could be root 25 times root 2. The square root of 25 is 5, so 50 could be this, which means over here, when I broke this down into root 4 times root 50, it was 2 times the square root of 50. We just found out that the square root of 50 is 5 root 2, and now if we multiply those together, we get 10 square root of 2, and that is our simplest answer for that one. If we had chose to go more direct, and I think this is the simpler way to do it, square root of 100 times the square root of 2 multiplies to root 200. The square root of 100 is 10. So our answer is 10 square root of 2. Same answer as the other way, but a lot less work and less chances to make mistakes. Here's our next example with the square root of 82. 82 is not on this list. It's an even number. However, 4 doesn't go into it evenly. So what I could do is break it down into smaller numbers. 41 times 2 is equal to 82. But here's the situation. 41 can't go any further. 2 can't go into any further. Neither one of them are perfect squares. So this one actually doesn't simplify. We don't write prime. We would just say that in simplest radical form, this one would be square root of 82 because it didn't go any further. The section we're going to be looking at next, we are going to be simplifying radicals and also simplifying fractions. And so this is a common problem that we're going to see as far as having 2 terms in the numerator, a binomial, and only 1 term in the denominator. The key here is to realize that there are 2 terms in the numerator, so it's not a bad idea to put parentheses and think about what will go into not just the number 9, but what will also go into the 3x, and what will go into 15, what will go into all 3 of those terms. And as I can see that 3 will go into all of them, we can divide them each by 3. 3x divided by 3 is x. 15 divided by 3 is 15. And in the denominator, 9 divided by 3 is 3. Parentheses optional, but here is our simplified form of the original. Next problem. What's going to go into these 1, 2, 3 terms? Let's see, I want to take the biggest number out that I can. If I don't take the biggest out, I can always simplify later, but it's always nice to start with the biggest if possible. And I see that they're all even, so I'm going to divide them each by 2. 18y divided by 2, 24x divided by 2, and 32 divided by 2. So we're back to the problem with having 3 different terms. And is there anything that goes into all 3 of these terms? I don't think so. 12 and 16 could both be divided by 4. 9 and 12 could both be divided by 3. But 9 and 16 don't have anything in common. So this is our simplified form. The reason why we simplified those previous polynomial expressions is so we could get to a problem like this. Once again, it's a binomial. There's 2 terms in the numerator. I want to know what's going to go into 5, also going to go into 10 square root of 3, and 25. And what I see is, in each of these terms, I can divide them each by 5. 5 divided by 5 is 1. 10 root 3 divided by 5. Well, the root 3 is stuck underneath the square root sign. I'm not looking really to simplify with that. It's almost like it's a variable. But if I divide this by 5, I'm really dividing the coefficient by 5, which would make it become 2 root 3. 10 divided by 5 is 2. This is 2 root 3. And in the denominator, 25 divided by 5 is 5. There is our simplest form for this one. Here is our next problem. I encourage you to pause for a second, take a look at it, and try to determine what can go into these 1, 2, 3 terms. What I see is that 3 will go into all of them. 6 divided by 3 is 2. 9 root 2 divided by 3 is 3 root 2. And 24 divided by 3 is 8. They don't have anything else in common, so there is our simplest form. And here is the last one. Good habit to put parentheses around those. And again, I'd encourage you to pause here for a second, really think about the problem and what will go into these 1, 2, 3 terms. What I see is that 2 will go into all those coefficients. 16 divided by 2 is 8. 10 root 10 divided by 2 would be 5 root 10. We can't touch that number on the inside. It stays what it is. We're not dividing by root 2. We're dividing by 2. So we're dividing the outside number by 2. And in the denominator, when we divide that by 2, it becomes 1. And we know that anything divided by 1 is itself, so we could even ignore that denominator and write this as our answer.